Today we're exploring the essential steps of data science methodology. Before jumping into code, it's crucial to understand the entire lifecycle of a data project. This journey starts with grasping the business requirements and defining clear objectives. From there, we move through data collection, preparation, analysis, and finally, deployment. Each phase plays a vital role in ensuring the project's success. By the end of this video, you'll have a solid overview of how data science projects are structured and why each step matters. Let's begin by understanding why methodology is the backbone of effective data science. Every successful data science project begins with a deep understanding of business requirements. This means engaging with stakeholders to clarify what problems need solving and what outcomes are expected. It's not just about the data or the algorithms, it's about aligning the project with real business goals. By asking the right questions and listening carefully, data scientists can ensure their work delivers true value. This foundational step sets the direction for the entire project, making sure that efforts are focused and relevant from the very start. Once the business requirements are clear, the next step is to define specific objectives for the data project. These objectives should be measurable and actionable, providing a clear target for the team. For example, instead of saying improve sales, a more precise objective would be increase online sales by 10% in 6 months. Clear objectives help guide the project, making it easier to measure progress and success. They also ensure everyone involved understands what the project aims to achieve. The objectives in place, it's time to plan and scope the project. This involves outlining the tasks, resources, and timeline needed to reach the goals. Planning helps identify potential challenges early and ensures that the team is prepared. Scoping defines the boundaries of the project, what's included and what's not. This step is crucial for managing expectations and keeping the project on track. A well-planned project is more likely to stay within budget and deliver results on time. Now let's talk about data collection. This step is all about deciding what data is needed and how to gather it. The quality and relevance of your data directly impact the project's outcomes. Data can come from various sources: internal databases, external APIs, surveys, or even manual entry. It's important to ensure the data is accurate, complete, and timely. A solid data collection strategy lays the groundwork for meaningful analysis and reliable results. Data acquisition involves the actual process of obtaining the data you need. This could mean extracting data from databases, scraping websites, or integrating with APIs. Each technique has its own challenges, such as dealing with missing values or inconsistent formats. It's essential to document where the data comes from and how it's collected. This transparency helps with future analysis and ensures the data can be trusted. Once data is collected, it often needs cleaning. Data cleaning is the process of correcting errors, filling in missing values, and standardizing formats. Clean data is essential for accurate analysis. This step can be time-consuming, but it's worth the effort. By ensuring the data is reliable, you set the stage for meaningful insights and avoid misleading results. Data cleaning is a critical part of any data science methodology. Clean data in hand, the next step is data exploration. This involves analyzing the data to understand its structure, patterns, and potential issues. Data scientists use visualizations and summary statistics to get a sense of what's in the dataset. Exploration helps uncover trends, outliers, and relationships that might influence the analysis. It's a chance to ask questions and form hypotheses before moving on to deeper modeling. Feature engineering is the art of creating new variables or features from the existing data. These features can help improve the performance of machine learning models. For example, combining date and time into a single feature or creating categories from continuous values. Good feature engineering requires creativity and domain knowledge. It's a key step in turning raw data into actionable insights. Data preparation brings together all the previous steps: cleaning, transforming, and organizing the data for analysis. This step ensures the data is in the right format for modeling. It may involve normalizing values, encoding categories, or splitting the data into training and testing sets. Proper data preparation is essential for building robust models and achieving reliable results. Model selection is a critical decision in any data science project. The choice depends on the problem you're solving: classification, regression, clustering, or something else. Each model has strengths and weaknesses, so it's important to consider the data objectives and constraints. Sometimes it's useful to try several models and compare their performance. The goal is to find the model that best fits the data and meets the project's need. Once a model is chosen, it's time to train it using the prepared data. Model training involves feeding the data into the algorithm so it can learn patterns and relationships. This process may require tuning parameters and adjusting settings to improve accuracy. Training is an iterative process. Data scientists often go back and forth, refining the model until it performs well. The goal is to create a model that generalizes well to new, unseen data. After training, the model's performance must be evaluated. This step uses metrics like accuracy, precision, recall, or mean squared error depending on the problem. Evaluation helps determine if the model meets the project's objectives and if it's ready for deployment. If the results aren't satisfactory, it may be necessary to revisit earlier steps, collect more data, engineer new features, or try different models. Thorough evaluation ensures the model is reliable and effective. Auto validation is about testing the model on data it hasn't seen before. This step helps ensure the model isn't just memorizing the training data but can generalize to new situations. Common techniques include cross-validation and using a holdout test set. Validation provides confidence that the model will perform well in the real world, not just in the lab. Model tuning involves adjusting the model's parameters to achieve the best possible performance. This might mean changing the learning rate, the number of layers, or other settings. Tuning is often done through systematic experimentation, testing different combinations to see what works best. The goal is to maximize accuracy and minimize errors, ensuring the model is as effective as possible. For deploying a model, it's important to plan how it will be integrated into the business process. Deployment planning considers where the model will run, how it will be accessed, and what resources are needed. It also involves setting up monitoring to track the model's performance over time. Good planning ensures a smooth transition from development to production. Deployment is the process of putting the trained model into production so it can make real-world predictions. This might involve integrating the model into a web application, a business dashboard, or an automated system. Successful deployment requires collaboration between data scientists, engineers, and business users. The goal is to ensure the model delivers value and operates reliably in its intended environment. Once deployed, models need ongoing monitoring and maintenance. This means tracking their performance, detecting issues, and updating them as needed. Over time, data can change and models may need to be retrained or adjusted. Regular maintenance ensures the model continues to deliver accurate and valuable results, adapting to new trends and challenges. Feedback is essential for continuous improvement. After deployment, gather feedback from users and stakeholders to identify areas for enhancement. Iteration means revisiting earlier steps, collecting new data, refining features, or adjusting models based on what's learned. This cycle of feedback and iteration helps keep the project aligned with business needs and ensures long-term success. Thorough documentation is a hallmark of professional data science projects. Documenting each step, from data sources and cleaning methods to modeling decisions, ensures transparency and reproducibility. Good documentation helps others understand your work and makes it easier to maintain or extend the project in the future. Data science projects often involve collaboration across different teams: business, engineering, and analytics. Effective communication and teamwork are key to success. By sharing knowledge and working together, teams can solve complex problems more efficiently and create solutions that truly meet business needs. Ethical considerations are increasingly important in data science. This means respecting privacy, avoiding bias, and ensuring fairness in models and decisions. Data scientists must be aware of the potential impacts of their work and strive to build systems that are responsible and trustworthy. Data governance refers to the policies and procedures that ensure data is managed properly throughout its lifecycle. This includes data quality, security, and compliance with regulations. Good governance helps protect sensitive information and supports reliable, ethical data use. Every data project carries risks: technical, operational, or ethical. Identifying and managing these risks early helps prevent problems down the line. This might involve backup plans, regular audits, or clear escalation procedures. Proactive risk management keeps projects on track and protects the organization. As data projects grow, scalability becomes important. This means designing systems that can handle increasing amounts of data and users without breaking down. Scalability planning ensures the project can expand smoothly and continue delivering value as needs evolve. Managing costs is a practical aspect of any data science project. This involves budgeting for resources, tools, and personnel, and tracking expenses throughout the project. Effective cost management helps ensure the project stays within budget and delivers a strong return on investment. Regular communication with stakeholders keeps everyone informed and engaged. This includes sharing progress updates, discussing challenges, and celebrating milestones. Open communication builds trust and helps ensure the project stays aligned with business priorities. Introducing new data solutions often requires change management. This means preparing teams for new tools, processes, or ways of working. Effective change management includes training, support, and clear communication to help everyone adapt smoothly. Quality assurance ensures that every part of the data project meets high standards. This includes checking data accuracy, validating models, and reviewing code. Consistent quality checks help catch errors early and maintain the integrity of the project. Version control is a best practice for managing changes to code, data, and documentation. Tools like Git help teams track updates, collaborate efficiently, and roll back changes if needed. Good version control supports teamwork and project reliability. Reproducibility means that others can follow your steps and get the same results. This is vital for building trust and advancing knowledge. Clear documentation, version control, and standardized processes all contribute to reproducible data science projects. Automation helps streamline repetitive tasks in data projects such as data cleaning, model training, or reporting. By automating these steps, teams can save time, reduce errors, and focus on higher-level analysis and decision-making. Data visualization turns complex data into clear, actionable insights. Charts, graphs, and dashboards help communicate findings to stakeholders and support better decision-making. Effective visualization makes data accessible and impactful. Reporting is about sharing results with stakeholders in a clear and meaningful way. Good reports highlight key findings, explain methods, and provide actionable recommendations. Regular reporting keeps everyone informed and helps drive business value. For data science to have real impact, solutions must be integrated into business processes. This means working closely with business units to ensure models and insights are used effectively. Integration turns data science from a technical exercise into a driver of business success. Training users on new data tools and processes is essential for adoption. Effective training covers not just how to use the tools, but also how to interpret results and make data-driven decisions. Well-trained users are more likely to embrace new solutions and achieve better outcomes. After implementing new data solutions, it's important to evaluate their impact. This means measuring whether objectives were met and identifying any unexpected outcomes. Change evaluation helps organizations learn from experience and improve future projects. Data science is an ongoing process. Continuous improvement means regularly reviewing and enhancing models, processes, and tools. By staying curious and open to change, teams can keep delivering value and stay ahead of the curve. Sharing knowledge within and across teams accelerates learning and innovation. This can include presentations, documentation, or informal discussions. A culture of knowledge sharing helps everyone grow and improves project outcomes. The world of data is always evolving. Adapting to new technologies, methods, and business needs is crucial for long-term success. Flexibility and a willingness to learn help data science teams stay relevant and effective. Recognizing achievements and celebrating milestones boosts team morale and motivation. Whether it's completing a challenging project or reaching a key goal, taking time to celebrate helps build a positive team culture and encourages continued effort. Not every data project will succeed, and that's okay. Learning from failures is just as important as celebrating wins. Analyzing what went wrong and why helps teams avoid similar mistakes in the future and fosters a culture of growth and resilience. Data science is a fast-moving field. Staying current with the latest tools, techniques, and trends is essential. This might involve attending conferences, taking courses, or reading industry publications. Continuous learning keeps skills sharp and projects innovative. Let's recap the data science project lifecycle. It starts with understanding business needs, defining objectives, and planning. Then comes data collection, cleaning, exploration, modeling, and evaluation. Finally, deployment, monitoring, and continuous improvement ensure lasting value. Each step is interconnected, and success depends on following a structured, thoughtful approach. Congratulations, you now have a comprehensive understanding of the data science methodology and the lifecycle of a data project. By following these steps, you can approach any data challenge with confidence and clarity. Remember, the key to success is not just technical skill, but a structured, thoughtful process from start to finish. Stay curious, keep learning, and apply these principles to your next data project.